Hello and welcome. My name is Brett Schuhart, and as I promised in the last video, I'm going to remove duplication between add and subtract. What you see before you is the add class. This is as I left it last video. Here is the subtract class, and I'm going to do something here. Copy a couple lines, and I'm going to save that. And if I switch between add and subtract, you'll notice I am switching files, but sure enough, they're pretty much the same. So I want to make that duplication as much as possible go away. This is going to be a refactoring exercise. I'm going to change the structure of the code without changing its behavior. So first of all, behavior. Are the tests passing? I'm going to run the tests. All the tests are running, so that means I'm ready to go. So I'm going to go ahead and introduce a intermediate base class. I'll call this a binary math operator, and it will be a math operator, sure enough. And I need some code. So I'm going to copy the code from subtract, and then I'm going to try to remove the part that's specific to each of the subclasses and delegate. Okay, so this is the base method. It's going to acquire two parameters. It's then going to actually perform the work and then store the results. All right, so what I'm going to do for now, until I come up with a better name, so here's a method. Now, I actually want to make this abstract. Execute implementation taking in two values. So let's see. All right, so there's our method. Let me see if I can get that on the screen a little bit better. There's the whole thing. All right. Now, of course, I need to make this an abstract class. Okay, what I'll do now is I'm going to change this so that instead of actually performing the work here, there we go. So now this is the base method, and in fact I could even go so far as to make this so that subclasses aren't supposed to override the execute method. Alright? So far so good. I run my tests, nothing breaks. Now I'm going to go back and modify subtract. So instead of subtract implementing math operator, it's going to extend now can no longer override execute, but what it can do instead is there we go. That's all I've done to change it. Now let's see if the test still pass. Okay, I've just changed subtract, and I'm going to do the same thing to add. So let's see, I'll make add okay, and let's see if this passes. Excellent. Duplication removed. So notice now there's still add and subtract, but what's different is the only line of code that was different really between them has been pushed into the method, or sorry, into a method in the derived class, and that I've introduced an abstract base class that has the algorithm acquire the parameters, store the result, perform the calculation, but the perform the calculation is deferred to a subclass. This is the template method pattern. That's all this is. So you have a couple of steps that are common, then you have an extension point, and then you have the result. Now, I'm going to go ahead and add in a new operator now that we've got this. What I'd like to do is I'd like to add in multiply and divide. I'll just do multiply for now. So I'm going to make a new class, and I'll call this, actually, I'm going to, in fact, I've already got this test over here, an RPN calculator with two values. Okay, great. I'll just put the test here. This is interesting. If I do it this way, notice I'm going to have to make sure that the calculator now knows about this. All right, so I'm not testing multiply directly. So in fact, this tells me this is a false step. I want to actually be able to test multiply by itself before I ever even plug it into the calculator. So I'm going to take a step back. I'm going to create a new class. All right. I'm going to do this one quite a bit differently than the previous one. What I'm going to do is I'm going to actually create, I guess I'll create a stack. Right, so an operator stack, operand stack. Now I can do math, I guess multiply, and this class doesn't exist, so I'll create this class. This class is going to be a binary math operator, and it's going to return LHS.multiply RHS. Save that, close that. That line now compiles. So I know I just sort of wrote the test a little bit ahead of time. I guess I'm cheating a little bit there. I said in the very first video I would occasionally cheat, and there was an example of me cheating. And then assert 21 new big decimal of 21, and I guess it's going to be stack dot peak. Get that in there. So here's the test. Now notice I could actually just write this as a common test with a pre-populated stack. I could have also used a fake stack here if I wanted to truly isolate this, but I'm choosing not to do that. But let's see if this test passes. It does pass. Now, I said it cheated, so let's go ahead and remove the cheat. If I go to execute here, and then execute implement, okay, so I need to go back here and go to the multiply class. This is sort of obvious, but just to show you that the test will in fact fail, I expected 21, but it was null. So that line of code actually is getting executed. I know that now. I was pretty certain of it before, but now I know. So there's multiply. You can imagine divide being quite simple as well. So there's an example of removing duplication in add and subtract through using the template method pattern. Add just implements the one line of code that it needs to, and in binary math operator, all the common stuff was pushed up. In another video, I'm going to do this exact same operation. It's going to take a little bit longer, and I'm going to do it using a TDD style, and I'm also going to use a mocking library. That's a video that's coming up. Hope you enjoyed this short video.